Darkness. Not the darkness of night, but something older, something absolute. Deep beneath our feet, beyond the reach of sunlight, there exists a world we barely understand. A world carved by water and time. A world of stone and shadow. Caves. Most of us will never venture into these places. And perhaps that's for the best. Because the deeper you descend into the Earth's hidden chambers, the stranger things become. At the entrance, life feels familiar. Bats roosting in twilight zones. Insects crawling across damp walls. Moss clinging to rock where the last rays of daylight fade. But this is only the beginning. This is the threshold zone, a place between two worlds. Here, animals still remember the surface. They return to it. They need it. But go deeper, past the reach of any natural light. Past the point where temperature stops fluctuating with the seasons. Past the boundary where the outside world becomes a memory. Welcome to the Twilight Zone. Here, in near total darkness, we find our first truly strange residents. Cave crickets with legs twice the length of their bodies. Antennae that sweep the air like blind fingers, searching for meaning in a world without sight. Their eyes have begun to fade. Evolution doesn't waste energy on tools that serve no purpose. And in absolute darkness, what use are eyes? Scientists call this troglophily, the love of caves. These creatures can survive here, but they haven't fully committed. They're visitors, tourists in the deep, but they're not the strangest things down here. Because beyond the Twilight Zone lies something else entirely. The Deep Zone, where darkness becomes absolute, where silence is a physical presence, where the temperature never changes, the humidity never shifts, and time itself seems to stop. This is where evolution takes a different path, where biology breaks its own rules. In Romania, in a cave sealed off from the surface world for over 5 million years, scientists discovered an ecosystem that shouldn't exist. Movile Cave, a place fed not by sunlight, but by toxic chemicals seeping through rock. Hydrogen sulfide, methane, poisons to surface life. But here, they are the foundation of everything. Bacteria consume these chemicals. Fungi grow on bacterial mats. And feeding on both, creatures that look like they've arrived from another planet. Pale spiders with translucent bodies. Water scorpions with legs like stilts. Leeches that have never known blood. All of them blind. All of them colorless. All of them perfectly adapted to a world that would kill us in minutes. This is just one cave. One isolated pocket of evolutionary experimentation. But around the world, in the deepest, darkest chambers, the pattern repeats. The deeper you go, the stranger animals become. As if darkness itself is a sculptor, reshaping life according to rules we're only beginning to understand. And we've barely scratched the surface. Or rather, we've barely scratched the depths. Let's talk about what darkness does to a body, to a species, to the very blueprint of life itself. When scientists first began cataloging cave-adapted creatures, true troglobites, species that live their entire lives in absolute darkness, they noticed something disturbing. A pattern. Loss. Eyes that have shrunk to useless specks beneath the skin, or disappeared entirely, leaving only smooth tissue where vision once existed. Pigmentation erased, leaving bodies ghostly white or translucent, pale enough to see organs pulsing beneath the surface. Even metabolism slowed to a crawl, as if time itself moves differently in the deep. This is regressive evolution, the shedding of unnecessary complexity. But it's not about going backward. It's about going sideways. Because while cave animals lose some things, they gain others. In Kentucky's Mammoth Cave System, the longest known cave network on Earth, there lives a creature called the Kentucky cave shrimp, barely longer than your fingernail, completely eyeless. But its antennae? Extraordinarily long, covered in chemical receptors so sensitive it can taste a single molecule of food in millions of gallons of water. It doesn't need to see. It tastes the world instead. In the caves of Slovenia, the olm, a bizarre salamander the locals call the human fish because of its pale, flesh-colored skin, can live for over 100 years. 100 years. In complete darkness. Barely moving. Barely eating. It can survive without food for a decade. Its metabolism is so slow, so perfectly calibrated to the unchanging environment, that it exists almost outside of time. Like a biological clock wound down to its slowest tick. And its sensory system? Electroreception. the same ability sharks use to hunt. The olm can sense the electrical fields generated by living creatures. In absolute darkness, it hunts not by sight, smell, or even sound, but by reading the invisible electricity of life itself. This is the cave's gift. Take away light, and life finds other ways to perceive, other ways to navigate, other ways to survive. But these adaptations come with a cost. Cave-adapted species are exquisitely specialized, perfectly tuned to their specific environment, which makes them fragile. Change the temperature by a few degrees, they die. Introduce pollution into the groundwater, they die. Disturb the delicate chemistry of their isolated world, they die. Many cave species exist in only a single chamber, a single underground lake, a single crack in the earth that may be just a few hundred meters wide. If that place is destroyed, they're gone forever, and we're destroying them. Groundwater contamination, climate change affecting water tables, cave tourism disturbing ecosystems that have remained stable for millions of years. Species are vanishing before we even know they exist. In 2019, scientists discovered a new species of blind cave beetle in Croatia. By 2021, rising water levels had flooded its only known habitat. It may already be extinct. We are losing windows into evolution's strangest experiments, losing answers to questions we haven't even learned to ask yet. But there's something else happening in the deepest caves, something that challenges everything we thought we knew about the limits of life. There is a place in Mexico called Sistema Actun, the world's longest underwater cave system. Over 350 kilometers of submerged passages, carved through limestone over millions of years. Dark, cold, still, and deep within this flooded labyrinth, scientists found something unexpected. Life. Not just life. An entire ecosystem thriving in conditions that shouldn't support it. Remipeds. Ancient crustaceans that have existed virtually unchanged for over 300 million years. Longer than dinosaurs. Longer than trees. They swim through the darkness with rhythmic, hypnotic movements, their segmented bodies rippling like living sine waves. They are blind, colorless, and utterly alien. But here's what makes them truly strange. They're venomous. The only venomous crustaceans known to science. They inject digestive enzymes into their prey, liquefying tissue from the inside before consuming it. In absolute darkness, in an underwater cave, they are apex predators. This is what the deep caves reveal. Life doesn't just survive in extreme conditions. It thrives. It innovates. It becomes something new. In the Lechuguilla Cave in New Mexico, one of the deepest limestone caves in North America, microbiologists discovered bacteria living in complete isolation for over 4 million years. These bacteria have developed resistance to modern antibiotics. Antibiotics that didn't exist when they were sealed away. Antibiotics that wouldn't be invented by humans for millions of years. Somehow, in the deep darkness, these microorganisms evolved defenses against chemical compounds they had never encountered. As if they were preparing, as if evolution could see the future. It suggests something profound, that the basic mechanisms of resistance, of chemical warfare at the microscopic level, might be ancient, universal, written into the code of life itself. These caves aren't just isolated pockets. They're laboratories, time capsules of evolutionary history, and we've barely explored them. Over 80% of caves worldwide remain undiscovered or unmapped. And of those we have found, most have never been biologically surveyed. Every expedition finds new species. Every descent reveals something science didn't predict. In 2020, researchers exploring a cave in China discovered a species of troglodytic huntsman spider with a leg span of 12 centimeters. 12 centimeters. Completely eyeless. Hunting in absolute darkness using only vibration and chemical sensing. The largest obligate cave spider ever recorded. It had been down there, in that specific chamber, for who knows how long. Evolving, adapting, perfecting its form in isolation, until a human finally pointed a light into the darkness and saw it looking back. Or rather, not looking, because it has no eyes to look with. But the question remains, what else is down there? In the unexplored chambers, the flooded passages too dangerous for divers, the cracks too narrow for human bodies. What has evolution created in the deepest, most isolated places on Earth? What's waiting in the dark? There's a theory in evolutionary biology. It suggests that Earth's caves might be the closest thing we have to alien worlds without leaving the planet. Think about it. Isolated ecosystems, extreme conditions, chemosynthetic life, organisms that derive energy not from the sun, but from chemical reactions in rock. It's the same principle scientists believe could support life on Europa, Jupiter's ice-covered moon, where a vast ocean exists beneath kilometers of ice. Or on Enceladus, Saturn's frozen moon, where hydrothermal vents pump chemicals into pitch-black water. If life exists there, it might look like what we've found in Earth's deepest caves. Blind, pale, slow-moving, feeding on chemistry instead of light, thriving in eternal darkness. The cave animals aren't just strange, they're prophetic. They're showing us what life might look like beyond our world. And they're teaching us something else, something we often forget. Evolution doesn't have a direction. It doesn't move toward complexity or intelligence or anything we might recognize as progress. It simply moves toward fit, toward perfect adaptation to environment. And sometimes, that means becoming simpler, stranger, more specialized. The deeper you go into caves, the more life strips away everything unnecessary, everything excessive. What remains is pure function, biology distilled to its essence. In the Krubera Cave in Georgia, the second deepest known cave on Earth, plunging over 2,000 meters below the surface, scientists found springtails living at depths where the pressure is crushing and the temperature barely above freezing. Tiny arthropods, eyeless, colorless, thriving at a depth equivalent to standing beneath 2 kilometers of solid rock. No one knows what they eat. No one knows how they reproduce. They simply exist, at the edge of where we thought multicellular life could survive, pushing the boundaries deeper, always deeper. And that's the real revelation, isn't it? We thought we understood the limits of life. We thought we knew where it could exist and where it couldn't. But every cave we explore, every chamber we illuminate for the first time in millions of years, we find life, waiting, adapted, strange beyond imagining, but thriving nonetheless. There are creatures living in total darkness right now, beneath our feet, that have never known sunlight. Species that have been evolving in isolation longer than our entire genus has existed. They don't know we're here. They don't need to. The deepest caves on Earth remain largely unexplored. New passages are discovered every year. Chambers that have been sealed since before humans walked upright. And in each one, the possibility of life unlike anything we've ever seen. So the question isn't really whether animals get stranger the deeper we go. The question is, how much stranger can they get? How deep does the strangeness go? And what will we find when we finally reach the bottom? If there even is a bottom.